Okay, so we're going to talk about multiple angle formulas, product to sum, power reducing, and half angle formulas in this video. So let's start with our double angle formulas. And something that I want you to know about double angle formulas is that they're actually coming from your sum formulas for sine, cosine, and tangent. So for instance, these are the ones that I actually want you to memorize. The rest of them I will provide a formula sheet for on our next quiz, okay? So I want you to know how do you derive them, because that way it'll be easier to remember them. Well, let's think about our sine 2 theta. Well, wouldn't you agree that sine 2 theta is theta plus theta? Yeah? Okay, and then there I could actually use my sum formula. Sine of the first angle, cosine of the first angle, plus sine of the first angle, cosine of the second angle. So I end up with 2 sine theta, cosine theta when the angle is the same. So it's twice the angle, and that's where this formula that you see here is coming from. This is actual proof for that double angle formula. Does that make sense? Okay. The same thing is true for cosine. I'm going to use my sum formula that we learned in our previous section. Cosine, when we double an angle, it's the same as that angle plus itself. So the formula says I have cosine, sine, cosine, excuse me, minus sine. And when you multiply anything times itself, you're increasing the exponential power of it. So this becomes cosine squared theta minus sine squared theta. And that's the proof for cosine double angle formula. And then here we can actually use substitution for cosine. I can actually substitute a Pythagorean identity in there, can't I? Yeah. Okay, remember sine squared plus cosine squared equals 1. So I can actually substitute cosine squared theta with, and I'm going to end up with, so here's 1, I'm not writing. I can substitute that with 2 cosine squared theta minus 1. Because I'm doing direct substitution with that sine squared, so I could combine the number of cosine squareds that I have. I could do the same thing with cosine, substitute it with sine, and we're going to end up with 1 minus 2 sine squared theta. Okay? And then our tangent is also coming from the double angle formula for the sum formula for tan of theta plus theta. I'm not going to show you a proof of that, but this is what we end up with. Okay? Tan of that angle plus tan of that angle is twice tan of that angle. And then remember on this side of the formula we had tan of theta times tan of theta. Because it's the same angle, it ends up being squared. Okay, so let's take a look at an example where we're actually incorporating these formulas. Alright, so here's the first one. It says to find the exact solution of the equation in the interval from, it should be 0 to 2 pi. That's not interval notation, so let's go ahead and change that. This should be bracket, parenthesis, not including 2 pi, but including 0 as a solution. So here I'm going to actually use my first identity, cosine 2 theta, or x, doesn't matter, same thing. And notice that here I have cosine x by itself. So I want to substitute this with, remember I just showed you 3 formulas for cosine, that double angle formula. I want to substitute it so that I can eventually factor this and find a solution. Well, if I'm going to do that, I'm going to pick one of the 3 formulas that I just showed you where everything's in terms of cosine. And that was 2 cosine squared theta minus 1. So here's a direct substitution. 2 cosine squared theta minus 1 minus cosine x equals 0. So here what I did was, where this double angle formula was, I went ahead and I substituted for what it was equal to. And now I'm going to put this in descending order and determine, can I factor this? So let's go ahead and do that. Get 2 cosine theta minus cosine theta. Oh, I'm inconsistent there. And minus 1 equals 0. Is that factorable, guys? Good, here we get plus 1 minus 1 equals 0. Alright, so here we get cosine theta equals negative 1/2. Cosine theta equals 1. And on the unit circle, I know that in quadrants 2 and 3, cosine's negative. In terms of pi over 3, I'm going to have a half for cosine. So that's going to be 2 pi over 3 and 4 pi over 3. Zero. At pi, cosine's negative 1. So our answer, we have 3 answers. 2 pi over 3, 4 pi over 3, and 0. Okay, here it says use a double angle formula to rewrite the expression. So I want to rewrite this in such a way that I'm using a double angle formula. Well, can I rewrite 6 as 2 factors? Good. Okay, so let's start there. 3 times 2 sine x cosine x. And now, can this be substituted for one of my double angle formulas? Yes, which was? Okay. All right, so now I recognize that what I have here is sine 2 theta. So that's going to be 3 sine 2 theta. And that's all these instructions are asking us to do. It's saying rewrite it and then simplify and plug in an actual double angle formula. So we're going backwards in the formula. Yeah, and this should have been x. Yeah. All right, so let's take a look at this. And we're going to find the exact value of sine 2 theta, u, cosine 2u, and tan 2u. I'm so used to saying theta, so if I say theta, I'm referring to u. When they actually give us tan u, and it's telling me in which quadrant it's in. Which quadrant is this in?
First.
Good, the first quadrant. So I'm going to go into quadrant 1, and I'm going to draw a triangle. And let's call it u. They gave me tan, opposite, over adjacent, 3, 5. What is my hypotenuse? Alright, don't make the mistake of putting 4 in the hypotenuse. Why? Because the hypotenuse is the longest side. So here you actually have to carry out the Pythagorean theorem. 3 squared plus 5 squared equals root 34 after, I forgot my c squared. C squared, and then c equals square root 34. It's positive because we're in quadrant 1. So that's why I'm not taking plus minus square root 34. It's just plus because I know I'm in quadrant 1. So the hypotenuse must be positive, okay? All right, so now that I have that, for the formula of sine 2u, and I'm going to start writing theta because I'm just so used to writing theta. So I want to find the double angle for sine. The formula is sine theta, 2 sine theta, cosine theta. So in my triangle, I need to identify sine and cosine. So let's go back here. Sine of u is equal to opposite over hypotenuse, which is going to be root 34. So when I simplify it, I'm going to get 3 root 34 over 34. And I'm going to do the same thing for cosine. And I'm going to get 5 root 34 over 34. And then what I'm going to do is just a direct substitution. Wherever sine is, so here, I'm going to say 2, 3 root 34 over 34, and then times cosine, 5 root 34 over 34. So now that I substituted, I'm going to go ahead and simplify. Well, in the top, I know square root 34 times square root 34. What happens to that?
34.
Becomes 34. And 2 times 3 times 5 is? Or if it helps you, 2 times 5 is 10, times 3 is 30. Always go for the easier factors first. So now I know I have 30 times 34. I'm purposely not multiplying this. And I know in the bottom I have 34 times 34. I'm leaving it in terms of factors because right away I saw that I will be able to reduce 34. And I end up with 30 over 34 for my double angle for sine, which reduces to, and I get 15 over 17. Good. All right, now I'm going to do the same thing for cosine. Cosine. And cosine, I have some options. Remember, we have those 3 formulas, but I'm going to just choose this one. And I'm going to do a direct substitution here. Cosine we said was 5 root 34 over 34. We're squaring this, minus sine we said was 3 root 34 over 34. And squaring that. Okay, so when I do this, 5 squared is 25. Square root of 34 squared, I'm purposely leaving that like that. Why? Because when I square the denominator, watch. I get 34 times 34, but I'm leaving it alone, just like that in factors again. Why? Because I can reduce them. And then it's easier mental math, right? So here I'm going to do the same thing. 3 squared is 9. Square root of 34 squared is 34. That says times. In the bottom, I'm going to do the same thing, 34 times 34, and then my 34s are going to reduce. So in the top, I could just do, because the denominators are the same, I can join the fractions. 25 minus 9 is over 34, and that reduces to 8 over 17. And now we're just missing tan 2 theta. So we're going to do the same thing, tan 2 theta. Let's go ahead and substitute the formula here. That's 2 tan theta, 1 minus tan squared theta. I've put plus. So tan double angle is 2 tan theta over 1 minus tan squared theta. And tan is given to us. However, I want a shortcut. Yes, you can use this formula. Go ahead, substitute tangent at 3 over 5 here. And you're going to carry out the 2 times 3 over 5 over 1, 3 over 5 squared. Simplify all that. But I want to go a little bit faster than that. I know using my quotient identity and verifying proofs, because we've done a lot of that, but this is going to be equivalent to sine 2 theta over cosine 2 theta. And this is something that I did evaluate for. I did that up here. We got the double angle for sine here. We got 15 over 17. And we got the double angle for cosine, that's 8 over 17. As long as you evaluated for it, and this is what you're substituting, I'm okay if you use this shortcut. Do not make the error of substituting this. This is not the double angle of sine and cosine. That's the single angle, okay? So be careful with that. If you're going to single angles, you must use the given for tangent. But because I have the double angles, I'm going to shortcut. I'm going to go ahead and substitute, because I evaluated sine 2 theta, so I'm able to substitute. Sine 2 theta we said was 15 over 17. And cosine 2 theta we said was 8 over 17. And when I reduce that, I get 15 over 8. If you use this formula, you will see that you get the same solution. Alright, so let's talk about power reducing formulas. I am going to give you these formulas. So we don't have to come up with the proofs, even though we can, okay? This one I will give you on your quiz. The only ones, again, I want you to memorize are your double angles, because you need to know those for calculus. Here you have your power reducing formula for sine. Notice that I have sine squared theta is going to be equal to 1 minus cosine double angle over 2. Cosine squared theta, a u, 1 plus cosine twice that angle over 2. So the difference here is, for sine it's going to be 1 minus, cosine's 1 plus. Tangent is 1 minus over that 1 plus. Okay? Because you could take this over this, the 2's reduce, and that's where that formula is coming from. Alright, use the power reducing formulas to rewrite the expression in terms of the first power of the cosines. Let's take a look at this first one. Alright, so here what I'm going to do is I'm going to rewrite it in such a way that I have cosine squared theta times cosine squared theta. Because wouldn't you agree that that's cosine to the 4th power? Don't you agree? Yeah? Okay, good. Alright, and now here I could clearly see that I can do another substitution. Here, I could substitute this for my power reducing formula that was on the previous slide. And that's going to be 1 plus cosine 2x over 2. 1 plus cosine 2x over 2. Alright, and then what I'm going to do is I'm going to pull out the fraction I see. I see 1 over 2 times 1 over 2, don't you? The 2's in the denominator. So that's 1 over 4. I'm pulling out that fraction temporarily. I'm going to say hang out here, and I'm going to FOIL this. Okay? And I want to show you what happens when we FOIL that. So here I'm going to get 1 over 4. 1 plus, and then I'm going to have 2 cosine 2x plus cosine squared 2x. And now let me ask you a question. Am I done reducing the powers? What that means is, do I still see exponents? I still see exponents, so therefore I have not finished reducing the powers. When I'm reducing the powers, I want all the exponents to be gone. Well, guess what I could do over here again? I can use my power reducing formula one more time, except I have to be careful because this time it's twice the angle. So wherever the angle is, I'm putting 2 in there. Okay? So watch me substitute one more time. So I pulled out the quarters hanging out. Remember, that's for my denominators. Pulled it out, it's hanging out on the side. I have 1 plus 2 cosine 2x. And now I'm substituting here for my next power reducing formula. It's 1 plus cosine twice whatever that angle is over 2. Okay? So how many times that angle do I have on the far right, Brian? Okay, so now let's simplify that. So we end up with 1 over 4, 1 plus 2 cosine 2x, plus 1 plus cosine 4x over 2. At this point, you could either factor out all the fractions or distribute that quarter back. I don't care which you do, as long as you do it correctly. So let me show you doing a distribution. So I'm distributing, and I'm also breaking up that fraction too. So what I'm saying is do this. So that's 1 over 2 plus cosine 4x over 2. 1 over 4 plus 2 cosine 2x over 4 plus 1 over 8 plus cosine 4x over 8. And then I can combine these two, and then I'd be okay if you put it in descending order like that. I need a common denominator. When I do that, this becomes 2 over 8. So that's 3 over 8 plus 2 cosine 2x over 4 plus cosine 4x over 8. Oh, I forgot to reduce this one. This is 1 over 2. Okay? And then that would be your final answer. The reason we cannot combine these two is that the one is twice an angle and the other one's 4 times an angle, so they are not like terms. Okay? Alright, so I said that you could do this, or you could factor out all the fractions. It's completely up to you. So what do I mean by that? Let's go back here. Okay? I'm going back over here. I want to factor out this half. But in order to factor out a half, this needs to be over 2, this needs to be over 2. Okay? So that means I have to change them before I factor it out. So I need to multiply it by 2 over 2. It needs a common factor. So let me rewrite that from the top so you guys can see how I would do that. So 1 over 4, 1 plus 2 cosine 2x plus, and I'm going to write this as a half, plus cosine 4x over 2. So clearly I'm trying to factor out this half so that way I don't have any fractions inside those parentheses. Alright, so when I do that, I'm going to change these two fractions by putting this as 2 over 2. And in order to change 2, I need to multiply it by 2 as well. So that's going to be 4 over 2. So now I can take out the half. So I have 1 over 4 times 1 over 2. And then all the denominators are gone. The numerators stay. So I end up with 2 plus 4 cosine 2x plus 1 plus cosine 4x. These are like terms. Make sure you simplify out here too, so you can see that you get 1 over 8. Parentheses, 2 plus 1 is 3, plus 4 cosine 2x, plus cosine 4x. Again, these are not like terms. Please don't combine them. The reason being is one is double angle, another one is 4 times that angle. Alright, so our next set of formulas are known as our half angle formulas. And what we're going to do is we're going to double an angle and substitute that over 2. So remember those sum formulas where we had an angle such as 15, and that's not on the unit circle, so we came up with the sum of 2 angles that could, or the difference of 2 angles that could sum to 15 degrees, right? 45 minus 30 would give us 15 degrees, and then that would help me identify the exact value of 15 degrees. So that's exactly what we're going to do here. So we're going to be given an angle. However, it's not on the unit circle. So I'm going to think of what angle can I take half of so that I can find the exact value. And that's exactly what we're going to be doing. Something that I do want to point out is the signs. You see plus minus here. The signs depend on which quadrant the given angle lies in. Alright, so here's our first example. It says use the half angle formulas to determine the exact values of sine, cosine, and tangent of the angle. This one is not possible, so switch that to 105 degrees. Alright, so in order to figure out, and let's just do sine. I'm going to do sine of this one. So we're going to find sine of 105 degrees. So I'm going to double that angle. And when I do that, I get 210. So do you agree that 210 divided by 2 is 105? That's where that formula comes into play. Okay. 105 is in which quadrant? Second. And sine is what sign in quadrant 2? Sign is positive, so I'm going to take the positive, not the plus minus, okay, of whatever's in that formula. For this one, we have 1 minus cosine of theta, and it's theta that's here. This is the substitution that's going to, over 2, that's going to happen. So I'm going to go ahead and substitute 210 degrees into that formula. So that equals the square root of 1 minus cosine of 210 over 2. Okay, so cosine 210 is in quadrant 3, and that corresponds to negative root 3 over 2. So I have 1 minus, and then put that in parentheses, negative root 3 over 2, and that's over 2. So what we're going to do is we're going to simplify that, and that's going to become 1 plus root 3 over 2 over 2. You must simplify the numerator before simplifying the denominator. So that 1 is going to become 2 over 2, and that's going to become 2 plus root 3 over 2, and all of that is over 2. Be careful when dividing that. I see a lot of people want to reduce that 2 and make it go away. Don't do that. You need to do state, change, flip, and when you do that, you realize that, wait a minute, flip it. You get 4 in the denominator, okay? So when I rewrite it, I get the following. I get 2 plus root 3 over 4. And can you take the square root of 4? Good. So your answer is 2 plus root 3 over 2. And that's the exact value using the half angle formula. Okay, so here we're just going to evaluate cosine of 5 pi over 12 so you see what another example is like. So let's do cosine of 5 pi over 12. What you want to do is multiply this by 2 in order to find the angle that you need to reduce in half. Okay? So multiply it by 2. When I multiply it by 2, I can see that I get 5 pi over 6. So 5 pi over 6 divided by 2 is what's going to go in the formula, because when I do that, I get 5 pi over 12. So I'm going to find cosine of 5 pi over 6 inside here. But 5 pi over 12 is what's given to us, and this is what's going to establish whether I'm going to use the plus minus of the formula. 5 pi over 12 is in which quadrant? Okay, so we recognize that 5 pi over 12 is in quadrant 1 because 6 pi over 12 is pi over 2, and we're almost there, so the only sign I'm going to be using is that plus sign. And now we're going to take the square root. Let's fill in our formula. Our formula says the square root of 1 plus cosine of theta. Remember, the angle that we're substituting is this one. It's pi over 6, the one I can actually, I didn't write cosine, the one I can actually substitute in there, over 2. So let's go ahead and start substituting. 1 plus cosine of 5 pi over 6 over 2. And cosine of 5 pi over 6, we can evaluate that. Let's go ahead and evaluate that. We get equals the square root of 1 plus 5 pi over 6 is in quadrant 2. Cosine is root 3 over 2 there. And it's positive or negative, guys? Negative, good. Over 2. So the 1 is going to change to 2 over 2. Notice that once you get the hang of this, it gets a little bit easier, and I get 1 minus root 3. I'm sorry, I said 1, I meant 2 minus root 3 over 2 over 2. What did we learn happens with these 2's? It becomes a 4. No, you don't cancel them out. Flip it over, put it over 1, flip it over, and then you can see you get 2 times 2 in the denominator. Okay, so you get 2 minus root 3 over 4. Can I take the square root of anything?
4.
Good. So I end up with square root 2 minus root 3 over 2, and that's our exact value. Okay, let's take a look at this example. It says determine the quadrant in, and this should say half angle. This is a typo again. This should say over 2 lies, and find the exact value of sine, half angle, cosine, half angle, and then tangent, half angle, using the half angle formulas. Okay, so they give us tan. It tells us it's in which quadrant, guys? All right, so yes, we must be in quadrant 4. This is in quadrant 4. And tangent is negative in there. So when I set up my triangle, let's go ahead and set up a triangle in quadrant 4. I'm going to call it theta. Tangent is opposite over adjacent. Let's find the hypotenuse. Your hypotenuse is 13. So now that we have that, we can start finding the half angle of that. Remember, sine and cosine are using cosine of an angle inside the formula. So what I need is cosine of theta here. Cosine is adjacent over hypotenuse. And now let's actually find sine of the half angle. Let me show you that. So sine, I'm going to put theta over 2, is equal to 1 minus cosine of theta over 2. So notice that the only thing I have to substitute is this in here. That's what I'm asking you to do. So that's not too bad, right? So let's actually go ahead and do that. Equals 1 minus 12 over 13 over 2. Rewrite this so that you have 13 over 13, and you're going to get 1 over 13. So we get 1 over 13 over 2. Flip it over. Right? Put this over 1. Recognize that you're really doing 1 over 2, right? And you get 1 over 26. Can I take the square root of anything here? Edwin? 1. And then I end up with 1 over root 26. What do I need to do next? Rationalize that denominator. Good. So multiply the top and bottom by root 26. And I get root 26 over 26. Cosine of the half angle would be exactly what we just did, but instead of minus, it's plus. So I'm going to go over here, and I'm actually just going to switch it to plus, because if you go back to the formula, that's the only difference. So I'm going to do cosine of theta over 2 is equal to, and I'm going to go from here and just do plus. So I'm going to get 13 plus 12 over 13. And 13 plus 12 is over 13, and then over 2. Stay, change, flip, and you're going to get root 25 over 26, which is 5 over root 26, 5 root 26 over 26. That's the only difference in the formula for the half angle for cosine. So if you did one of them, all you have to do is go back here, switch the sign. Switch the sign. And that's exactly what you saw me do here. Now we're going to do the tangent. The half angle formula, we have a couple. I'm going to use, let's use this one. Tan of theta over 2 is equal to 1 minus cosine of theta over sine of theta. Well, guess what? We already found 1 minus cosine theta. Here it is. 1 over 13. So if we already started doing little bits here, don't redo the work. Just go back and be like, oh, I already evaluated this. Plug it in. So 1 over 13 for the numerator. And then sine, I'll just look at your triangle. Sine is opposite over hypotenuse. Stay, change, flip. And our answer is negative 1/5. Alright, so it says use the half angle formulas to simplify the expression. Here you just have to identify which half angle formula was used. Well, in order to get the 1 minus, I must have used sine, right? Sine of some angle. Well, this is the one that goes in the formula, right? Just bring it out. Can I reduce that? Okay, and then your answer is sine of, that's your answer. Because we're undoing the square root, we know based on what I told you before that you have to be in quadrants 1 or 2. So this here, by practice, should be the absolute value of sine 3x, okay? All right, example number 8 says find all solutions of the equation in the interval from 0 to 2 pi with a bracket here. After we solve it, go ahead and use a graphing utility and verify your solutions. So the only thing I'm interested in doing here is starting by substituting my half angle formula. So the one that I'm interested in is plus minus, I'm not writing, plus minus the square root of 1 minus cosine theta over 2. Plus cosine, I said theta, so let's keep it theta equals 0. Okay, the next thing I want to do is isolate the square root so that way I can take the square of both sides and get rid of the root. Okay, so plus minus 1 minus cosine theta over 2 equals negative cosine theta. Now I'm going to take the square of both sides and watch what happens. I get 1 minus cosine theta over 2 equals cosine squared theta. How do I get the fraction out of the denominator? Multiply both sides by 2. And to keep everything positive, I'm going to bring everything over to the right side. So I'm going to add cosine. And I'm going to subtract 1. Is this factorable? Yeah. Okay. So here we get 2 cosine theta. Cosine theta. I want my middle term to be positive, so this one has to be my plus 1. This one has to be my minus 1. And now I'm going to set each binomial equal to 0 and solve that on the unit circle. So one of my solutions is going to be cosine. Let's go ahead and move this up. One of my solutions is cosine theta equals 1/2, and the other one cosine theta equals negative 1. Okay, so theta equals pi over 3 and 5 pi over 3. And for negative 1, it's pi. Good. And here are all your solutions. Verify that using the graphic utility. So this is something similar that we've been viewing before this. What we're going to do is we're going to take the product of two terms for sine of one angle, sine of another angle, and we're going to break it up into either the sum or difference of something. So let's take a look at an example. Here it says, use the product to sum formulas to rewrite the product as a sum or difference. All right, so here are those formulas again, and our first step is to identify which one of these was used. So here I have sine of an angle times sine of another angle. So I'm looking for the sine of an angle times the sine. So this is the one I'm going to use. So I'm going to use that to set up my difference. So I'm going to take half of cosine of the first angle. So this one's going to be u, this one's going to be v. So I'm going to substitute it just like that. So 5 theta minus 3 theta minus cosine of the sum of those two angles. So 5 theta plus 3 theta. And then we just simplify in the brackets, and we end up with cosine of 2 theta minus cosine of 8 theta. And then just distribute the half, and that's going to go in the front. And you cannot combine these. 2 theta and 8 theta, those are the angles. So double angle and 8 times an angle is not the same angle, so we cannot combine these two terms. All right, so something very similar is sum to product. So this time I'm going to go backwards in it. So I want to take something where I'm adding two terms and combine it to a single term. So here's an example of that. We're going to use the sum to product formulas to rewrite the sum or difference as a product. And again, we want to be able to identify what is being used here. Well, sine of 5 theta minus sine of 3 theta, that's very similar to this one. So this is the formula that I want to use in this example. So let's go ahead and start substituting. Remember, this is u, this is v in the formula. So we're going to do 2 cosine u plus v, so 5 theta plus 3 theta over 2, sine, and now we're going to do the difference, over 2, and we're going to simplify this. 5 plus 3 is 8 theta. When we divide that by 2, we're going to get 4 theta, so we get 2 cosine 4 theta here. 5 minus 3 theta is 2 theta. Over 2, we're going to get theta, so sine of theta. And that's our answer. Here, this time we're going to find the exact value of the expression. So we're going to take those sum to product formulas. Let's identify which one's being used and find the exact value. All right, so here we're going from the sum, and that's what I see here. So this is where I'm going to substitute. Remember, this is u, this is v. All right, so let's start substituting. Again, this one is u, this one is v, and the one that we're going to be using is this top formula. So that is 2 sine 75 plus 15, we're going to divide that by 2, cosine 75 minus 15 divided by 2. And here we're going to get 2 sine 90 divided by 2, and that's degrees, cosine of 60 divided by 2, and that's in degrees. So let's simplify that. We get 2 sine 45 degrees, cosine 30 degrees. And now we can use a unit circle to substitute the values. We know for sine of 45 degrees, which is root 2 over 2, and cosine of 30 is 1/2. It's root 3 over 2. Okay, when we simplify this, we end up with root 6 over 2.